Hello, and welcome. You know that glowing rectangle in your living room? The one on your desk, or maybe the one in your pocket right now? It is an absolute marvel of engineering. So today, we're gonna pull back the curtain and tell the story of how it actually works.
Okay, picture this. You walk into an electronics store, and you're just hit with this giant wall of TVs. They all look amazing, but the labels are a total mystery. What actually separates one from the other? Well, that is the exact question we're gonna answer today.
It really is an alphabet soup of technology, isn't it? But don't worry, all of these acronyms, they actually tell a story. It's an evolutionary tale of how engineers have learned to completely master light, and we're gonna make sense of it all starting right from the beginning.
So for decades, the television was the cathode ray tube, or CRT. Yeah, these were those giant boxy TVs a lot of us grew up with. And let's be honest, they had some serious problems. I mean, they were incredibly heavy, they took up a ton of space, and they used a ridiculous amount of power. The world was just desperate for something thinner, lighter, and way more efficient. And that's where the flat panel came storming in. After decades of work, the 2000s saw a total revolution. By 2007, we hit this major tipping point, and the era of the big, bulky CRT was officially over. The liquid crystal display, or LCD, had taken its place as the brand new standard for pretty much every screen everywhere. So how does this new technology even work? Well, unlike a CRT, which literally shot electrons at a screen, wild, right? An LCD works on a completely different principle. It's all about controlling light that's already there. It's the art of blocking light. Okay, this right here is the single most important thing to understand about an LCD screen. The pixels themselves, they don't actually glow. They're basically a million tiny shutters. And behind all of those shutters is one big lamp, what we call a backlight. The entire magic of an LCD image comes down to how well it can open and close those tiny little shutters.
The best way to think about it is like a carefully constructed light sandwich. So at the very back, you've got your backlight, and that thing is always on. In the middle, you have the liquid crystal layer, which twists and turns to either block or pass that light through. And then, right at the front, you have red, green, and blue color filters. By combining these three steps for every single pixel, millions of times over, you get a full color image.
This diagram shows us that light sandwich, but for just a single pixel. So over on the far right, you see the backlight. That's the bread. It's always on. Now, as the light travels to the left, it hits the liquid crystal layer. That's the filling. It twists to decide if this tiny little dot should be bright or dark. And then finally, it passes through a color filter to become either red, green, or blue. Now just multiply this by millions, and you have the entire image on your screen. Pretty cool.
Okay, so if that's an LCD, then what on earth is an LED TV? I'm telling you, this has been the biggest source of confusion for shoppers for well over a decade. And the truth is, it's basically a marketing trick.
Yeah, let that sink in for a second. An LED TV is an LCD TV. It's not some brand new type of screen. The only thing that changed was the kind of light bulb they used for the backlight. The liquid crystal shutters and the color filters, they're all still there, and they're all working in exactly the same way.
So while it wasn't a whole new screen technology, this was a huge upgrade to the backlight. See, the old TVs used these bulky fluorescent tubes. Think of them like miniature office lights. They ran hot, wasted energy, and even had toxic mercury inside. Switching to these tiny, super efficient light-emitting diodes, or LEDs, well, that changed everything. Just this one single change made TVs dramatically thinner, it used way less power, and it was much better for the environment. But the biggest leap, honestly, was in picture quality. Because LEDs are so small and so responsive, you can have groups of them dim down or even turn off behind the dark parts of an image. This is called local dimming, and it was a massive step forward for creating deeper, darker blacks and way better contrast on an LCD screen. So, improving the backlight? That was a fantastic evolution. But what if you could solve the LCD's core problem entirely? Engineers looked at that whole light sandwich thing with its always-on backlight, and they asked a truly revolutionary question. You know, what if you could just get rid of the backlight completely? What if every single one of the millions of pixels on your screen could be its own tiny microscopic light bulb that you could turn on, turn off, or dim all by itself?
And that answer is OLED. With an OLED TV, there is no light sandwich. The screen is what we call emissive, which means each individual pixel is its own tiny light source. You pass a current through an organic film and boom, it glows. No backlight, no shutters. The pixel is the light. And this table just brilliantly illustrates why OLED is such a total game changer. An LCD can never be truly black, right? Because the backlight is always leaking through just a little bit. But an OLED pixel, it can simply turn itself completely off. And that gives you perfect absolute black, and what we call an infinite contrast ratio. The difference between the brightest possible white and the darkest possible black.
But of course, the quest for the perfect picture isn't over, not by a long shot. In fact, those two fundamental ideas we've been talking about, filtering a backlight versus creating light at the pixel level, that's what continues to shape the future of screens.
So on one path, we have these really advanced evolutions of LCD. QLED adds a layer of quantum dots for better, more vibrant color, while Mini LED uses thousands of teeny tiny LEDs for even more precise local dimming. But the true revolution on the horizon is Micro LED. It takes that per-pixel light concept from OLED, but it uses inorganic materials, promising perfect blacks with even higher brightness and a longer lifespan. It's potentially the best of both worlds.
The journey from a bulky tube to a wall of pure light has been absolutely incredible to watch. And as the technology gets closer and closer to perfection, able to replicate reality with flawless accuracy, it really leaves us with one final question. When our window to the world can show us anything, what will we choose to look